So I'll be talking about how you can tackle some of the routing security issues. Doug has already explained what can happen if you don't do the right thing. If you are not protecting yourself from misorigination or the hijacks, then what can happen? So there are certain things you should do. So let me explain what are those things. If you are attending this session, this shouldn't be a surprise to you. There are more than 74,000 networks on the internet and around more than 1 million routes, IPv4 and IPv6 combined together. So there's a lot of addresses, there are a lot of networks on the internet. So before you connect, I give the same example. Whenever if you have a house, an apartment, you have to do certain things to make sure that it is secure. You place nice locks in your front gates. At places you put cameras for monitoring, make sure that everything is intact and everything is in perfect order. So you do certain things for your own infrastructure as well when you connect to the internet. And those things are you create objects in the IRR databases, you create ROAs in RPKI, you update your information in the peering DB, and you make sure that it is up to date. So these are called routing etiquettes. Whenever you connect to the internet, and if you are running a network, you should implement all these things. And that's what we did. I work for Internet Society. We do have a research network. We have the resources from APNIC. So we have two nodes. One is in Sydney, another one is in Zurich. So we have updated everything as any responsible network on the internet. You can have a look at our ASN and find all these details as well. If you look up the route objects, they are created in APNIC IRR database. And we have been announcing our prefixes according to the RIPRIS database as well. Similarly, we have created ROAs, which is the route origin authorization for our prefixes originating from our own AS. So 2/24s, one is coming from Sydney, another one is coming from Zurich. They have both valid ROAs. And the third thing which I mentioned is the peering DB. Again, it's a database where you provide all the details that where you are peering, which facilities you are in, what is your AS set if you have one, and how can you contact us. So if you go down on that page, there are more details about the contact. So email address is there just in case if something goes wrong, you can reach out. There's a Twitter handle, all this information which can be beneficial for any other network for troubleshooting anything or to contacting us. So the problem is, as Doug was explaining, it's of course there are too many networks. You have to make sure that you provide the right information to everybody else to make sure that they can protect you from anything happening to your network because it's all interconnected. So you have to provide the right information. You have to make sure the IRR database, the route objects are there, RPK ROA is there, peering DB information is up to date. So in the normal terms, what we call it is help me to help you. The problem is, which when Doug was explaining the seller hijack, cryptocurrency hijack, he did mention about the AllDB entry, which was not accurate. And that is the problem. The IRR ecosystem is based on Honor. There are IRR databases which are operated by RIRs, which are the regional internal registries. APNIC is in our region, and there are 4 others for other regions. But there are IRR services which are provided by third parties. For example, RADB, AllDB, and there are many other service providers who provide IRR services as well. So it can have some really it can have bad data in it, misleading information in it. Anyone create route objects for your prefixes or for your region as well in those databases. So what we call it is unauthenticated databases or unauthenticated IRRs. All the IRR services provided by your regional internet registry, which is, for example, APNIC, they are all authenticated. You cannot create route object for any other prefix other than your own. So that helps a lot in terms of security. So what we did is we looked up the RADB data and check how many misleading objects are there in that database. So the data is available publicly. You can go to this URL at the bottom and have a look at it. We publish this data every 15 days. So you can, if you want to check with the passage of time, if anything has changed in last couple of months or not. So I have only looked at the Taiwan data. So networks from the Taiwan and the details are something like this. For example, if there is a prefix allocated, so this is the delegated APNIC delegation entry 1.0.4.0/22, which is 1000 IPs, allocated in 2011. But if I look at the RADB, there are 4 different route objects, right? One object is saying that it is originated by AS560203. Another one is saying 24130, and third is 7545, and fourth one is saying 38803. So there are 4 objects. All 4 objects are created by an entity in Australia, which is aapt.com.au, in different times. So one is created in 2021, another one is 2013, and so on and so forth. So they have been creating route objects for different origin ASs for the same prefix. If I look up the route objects with origin of Taiwan ASN allocated to Taiwan networks, then you will find a lot of route objects in RADB. So if I look at them, the predominantly it is the origin is AS4780, and then there are other ASs in the list as well. And who is creating those object is rightly it's at the rate fareast1.com.tw. So it's the same service provider who's creating a lot of objects with their own origin AS, but they are also creating objects for other networks as well. In the list, you can find out the data, as I said, is publicly available. If you want data for your own network, I can provide you that separately. So if you look at it, so more than 10 objects created for the same origin. These are, you will find these ASN in the origin. If the origin AS and the maintainer AS is same, it means that it was created by the same service provider. But in some cases, you will find it's different. For example, here 17408 is the maintainer, where the origin AS is 38851. It could be a subsidiary of the same network or a sister concern, but it is created by other entities. If you look at all the domains, mostly are from Taiwan. So most of the objects are created by network entities in Taiwan for Taiwanese networks. That was for exact delegation or allocation. For example, if I have received a /22 from APNIC, these route objects are for the exact /22, but we know that you can create route object for more specifics. For example, I can create route object for /24, /23 from the same /22. If I look at the more specific from the Taiwan networks, again, you will see 9674, 4780, and 9416 being the most dominant ASN being as the origin AS. One example is this. For example, this maintainer AS4780 has created route objects which are more than 13,000 route objects with origin AS of 9674. But if I look at 9674, they are only advertising 65 routes. So, and if I combine the V6, they are still around 100 prefixes they are announcing. Then what is the reason to have more than 13,000 route objects? Similarly, it's for 9416 and 9919. There's just too many route objects, stale objects exist, which are not being advertised by these origin AS at all. So who is creating these objects? As I mentioned, it's mostly fareast1.com.tw and @hgc.com.hk domain. They have created more than 9,000 objects for 9416. The list is is long. So it's someone from Mike Lee 0987 @gmail.com has created more than 3,000 objects. Hutch City, Taiwan Mobile, Dongfeng. So there are a lot of, for example, aptg.com.tw, they have created objects for many origin ASNs. Not for one or two, but many of them. Most likely their customers. So if I look at who has created the most, of course, again, no surprises. Anyone who has created 13,000 objects is going to be the winner. So it's problematic in that sense. Let me go before going into the RPKI. So what is the problem I'm trying to highlight here? The problem is, of course, out of those 13,808 objects, only 100 are in the routing table. So anyone can actually misuse the remaining 13,700 objects. And that is the problem. You are creating a loophole in the routing registry where you can actually use any of the stale object and started announcing it. And someone who's not doing actively, not actively dropping routes on the basis of RPKI, of course, it doesn't have a valid route ROA, but it has a valid route object. If someone is only protecting their network on the basis of route objects, then they will accept it because it has a valid route object. So that is the problem. That problem can be easily fixed by if everyone only uses APNIC IRR database, which is authenticated. So that will not be a problem. Talking to Cheng Heng previously, TWNIC doesn't provide IRR services, but you themselves, but they provide you through APNIC. So ultimately, your route objects should be in the authenticated IRR database rather than in the RADB. And if your ASN is listed in one of the list as an origin, you can contact RADB and ask them to delete those objects. Now, the biggest and the better fix is using RPKI. Of course, there are no duct tapes involved in it. First thing you have to do is create the ROA, and the second step you have to do is enable route origin validation and drop the invalid routes. You are not protecting yourself only, you are protecting the whole ecosystem, not only in Taiwan, but also in globally. As Doug mentioned, Taiwan has done a really good job in terms of creating ROAS. There are more than 91% valid valid ROAS for all the routes originating from Taiwan, which is really remarkable because if you look on the left side, this is the global percentage. Globally, it's around 41% or 42%, depends upon how you are calculating it. But if you compare it with Taiwan, the numbers are really, really good. It's more than 91%. The only problematic part I see is 3.6% of invalids. Remember what Doug says, most of the big operators are now dropping invalids. If a operator is dropping an invalid, it means 3.6% routes from Taiwan are actually not making it to the global routing table in the best possible path. Probably they are reaching it to some part of the world, but not completely, because a lot of operators are dropping it, and the path they are taking is suboptimal. So make sure that you look at your ROAS and see if there are any invalid ROAS in the list you have created. To make it simple for you, these are all the invalids. I have looked it up. So if you are a network operator and your prefix is listed here, you can go to your portal and then delete those ROAS because they are invalid, because it doesn't match with what you are advertising. Make sure that you only create ROAS for what you are advertising. Otherwise, they are all invalid. So if you are part of 18412 or 63199 or 1280, please make sure that you delete those invalid ROAS and bring that 3.6% invalid rate to maybe 0, which is the best case scenario. Now, enabling the route origin validation, right? So this is the second step in the RPKI. The first thing is you have to do is create the ROAS. You protect yourself by creating ROAS. And then you protect everybody else by doing route origin validation. It is also, so Taiwan is also doing good in terms of route origin validation. Many operators in the country are actually dropping invalid, but of course not everyone. To make it simple for everybody, I would say everyone should do it, unless you are a stub network and you don't have any downstream customers. I think it would be a good idea to start doing route origin validation. In last 1 year, what we have seen, there are some misoriginations happening from networks in Taiwan. We monitor this through Manners Observatory. If you want to have a look, go to observatory.manners.org, and you will find all the details globally and for Taiwan as well. So if you want to know if your network was part of any of the misorigination on leak, you can reach out to me and I can provide you the details about your network. You can also apply for a observatory account by joining as an aspirant account, or you can join Manners Initiative as well if you are doing the right things. The last one is the peering DB. As mentioned, that PeeringDB is a database which provides you all the details about your network to the global, to the world. For example, how to contact you, where you are peering, which facilities you are located. It also gives you an important data point, which is called AS-set. If you are active in the APNIC policy arena, where Ching Hang is one of the chair, we have concluded an AS policy, AS-set policy, where we are now restricting anyone from creating an AS-set which is not a hierarchical AS-set. What is a hierarchical AS-set? Just give me a quick example. Anything marked in green is a hierarchical AS-set, where your AS comes first before the name of the AS-set. So this is authenticated AS-set. No one can create this AS-set on your behalf. But anything else I can create with your name. I can, for example, there is an AS set called AS-TPIX. I can create an AS set called AS-TPIX1. That's it. So I can create anything with the names. If it only involves names, I can create anything. That means I can create the same AS set in different IRR databases. If it is created in APNIC database, I can create one in RADB. I can create, if it is only created in RADB, I can create one in APNIC because they are not authenticated. APNIC cannot restrict me from not doing that. So it creates a problem. So these, if you are part of any of these networks, please make sure that you do not remove or update your AS set into hierarchical AS set. This is not the best practice, and now it is not possible to create one in APNIC database anyway. So please update them. It's a very big problem. I wrote about it in the Manners blog that how some entities misuse the AS set names and create problems for Amazon and Google not so long ago. So the list is long. Please make sure that you review this list, and if your network is part of it, please fix that. Anyone marked in green, you are doing a great job. You have already created the authenticated AS set. So the solution, do not rely on the third-party IRR databases, RADB, AllDB, or any other third-party or network database which is provided by a service provider. Rely on the IRR services provided by your National Internet Registry, which is TWNIC via APNIC. If also monitor route objects created in other private IRR databases. Use IRR Explorer. It gives you a detail of where your prefix exists in which database. So you can go and delete them and request to delete them from that database owner. RoApToIC is very good in Taiwan, so all kudos to you, but please make sure that you remove the invalids as well, just to make sure that your routing is optimal. And since the ROA uptake is so good, there's absolutely no reason to use IRR databases, for example, RADB or AllDB. So absolutely no reason. Encourage operators to implement ROV as well. Those who haven't implemented it, I saw someone asking question that what should be done. It is very simple. I do not operate an operational network anymore, but we do have a research network. What we did in that is make sure that we implemented on a edge device first and see if we are dropping something which we shouldn't be. And of course, because we don't have downstream customers, it wasn't a big problem. But if you have a downstream customer, maybe take that feed down to a separate router, your global routing feed, and implement origin validation and drop invalid on that and see the impact. First step, you can just pref or reduce, change the local preference according to the status of the RPKI ROA. If it is valid, then change it to something. If it is invalid, then change it to something else. So you can mark all the invalids you are receiving in your routing feed before you drop them. So this is important. These are all the safeguarding measures. Another one which Doug mentioned is the ASPA. And as someone was asking, what is the cost involved in terms of hardware and software? It is exactly the same as implementing RPKI. It uses the same RPKI framework. It just adds another object, ASPA object. I did a write-up on that on the Manners blog. You can go and read that. It details how ASPA objects works and how it can protect you from the path manipulation. But of course, you have to publish the right objects. So this is all from my end. If you are interested in getting all the details about your network, please reach out to me, and I'm more than happy to provide all the details. You can also log into the Manners Observatory, request for a free account, and I'm more than happy to look into that one. That's all from my end. If you have any question, I'm more than happy to respond.
Thanks, FTAP. Is there any question on the floor or online? You can put your question in on the chat, and we can, in Chinese or in English, we will explain your question to FTAP. After thanks for your speech, we learned a lot about how to tackle routing security. I have a small question about your slide. You spoke about if someone has created those objects for your resource, then contact IRR operators. Could you give more detailed information, or you give some example how to contact IRR operator? Is there any example?
Yes, for example, if someone has created a route object in RADB for your prefixes or for your ASN, just giving you an example, if your ASN is 139038, which is mine, and if I look up that ASN in RADB and see that there are route objects created with my origin ASN, with IP addresses which does not belong to me, I can simply send an email to their support saying, I do not authorize these route objects, please delete them. Because because they will verify you, they will send an email to the technical contact of my ASN, which is me, and say, do you authorize this to delete? And of course, I will authorize that to delete, and they will delete it. Yes, someone else can create it again. That is a problem. So you have to keep an eye that who is creating route objects on your behalf. It can happen with your ASN. It can happen with your prefix. ASN is, of course, I am not worried because I'm not going to advertise anything other than my own prefix. But that means someone else can hijack my ASN and start announcing prefixes, which, of course, does not belong to me. And who will get the blame? I will get the blame. So you always can, every IRR operator has a support contact. RADB has one, AllDB has one. You can reach out to them and say, please remove that route object. They will contact you through the admin.c or tech.c account, whichever is listed in your ASN or prefix, and you have to acknowledge that email, and they will delete it within 24 hours.
Okay, thanks, FTAP. There are some questions on the chart, and do you read it?
Yes, the encouragement I would say is very important is you are not if you are a service provider and you have downstream customers, then you are protecting all your customers from any hijack attempts coming towards them. Number one, I mean, if someone is sending you a fake IP address, you will protect them. They will not be able to reach out to that IP. So that is a good enough encouragement. Um, the second one would be if you are a service provider and how you want to implement it. As I mentioned, take that feed. Of course, you are connected to multiple upstream providers or the transit providers or the peering sessions. Take those feeds and drop it to in a lab environment somewhere, and implement those implement local preference on the RPKI decision. So we know that higher you can increase the preference of valid or invalid, decrease it for the invalid, and make sure that initially you do not drop anyone, right? And if you see any of your customer in the invalid list, reach out to them saying, by the way, you have invalid ROAS. Can you please remove them? Otherwise, when we implement the validation, your routes will be dropped. The only concern you should have is your own customers. What is happening on the internet, you end up dropping invalids on coming from the internet. It shouldn't be a bigger concern for you. So just drop the invalid, making sure that you're not dropping invalid of your customers. Once that is fixed, you can then drop the invalid. As I said, we have implemented it in our infrastructure because we don't have thousands of customers. It's only internal customers, so it's not a business problem. But yes, if you have many customers, it can be a business problem. Make sure that you do step by step. Job Snyder wrote a very nice script which can tell you how many invalids are there in your routing table. You can test it with that script as well. Otherwise, the easiest way is start implementing local preference on the basis of RPKI. If you do not see a lot of invalids coming in, then just implement it. It's easy.